Alright, so I'm just going to quickly start off with a recap of last time. So in Unity, you obviously have your hierarchy on the left side where you select your objects. You have your scene view where you can see your current scene, and the inspector where you can change parts of your currently selected object, and of course your assets folders where you have everything you've uploaded. So just to redefine it, a scene is just a group of objects. It's an area where you can create objects, have them move around, interact, and all. For instance, in video games, when you're loading from one area to another, you're unloading the scene you're in and then loading into a new scene. So yeah, basically just scenes or areas. Objects are just containers for components. Like you can see I have 3 components here in the camera, which is my transform, camera, and audio listen. All objects will always have a transform even if I create like an empty object. For instance, I'll go to 2D. You can right click in hierarchy to add things, by the way. I'll create a preset for an object, just a square sprite. And you can see it starts off with these. I'll just add, for instance, like the trail renderer. And now you can see, because it has the trail renderer component, now my thing has a trail. Basically, when you're coding in Unity, all you're doing is making your own custom components that will interact with the values of other components that you can see here. Also, you can, to save your project, you can see there's a little asterisk in the scene as well as the actual tab name. That means I haven't saved my current changes. So you can either file save or Control S. Now back to scenes. You saw how I was moving stuff earlier. I'll just quickly disable this trail render. And these are your main ways to do things in scenes. You have first your move tool. And by the way, these are binded to QWERTY, the QWERTY. So Q is just the move. You don't really need to ever go to this because you're going to mostly be on this one. And if you middle mouse click on any of the other ones, it becomes the hand. This one is it's the move tool. This was the view tool. You can see I have arrows. I can click and drag them to move my object in a direction. You can see the main thing this is doing is editing the transform component of this object. Or there's a blue square right there, and I can just hold it and drag if I want to not go in one axis. Next we have the rotate tool, which is pretty self-explanatory. It also changes the rotation in the transform. Then we have scale tool. You can scale in either direction. Next, this is specifically for rectangles and squares, the rect tool. It lets me just create the rectangle or change it to be any size. And then finally we have the transform tool, which gives me everything at once. I can rotate in 3D space technically, or this way, or scale, or move, and yeah. So, parenting. In Unity, parenting is, I'll do it for, first off, I'll make a second object, a triangle. Parenting is when you make an object tied to another object, so it'll follow the object, it'll rotate with the object, it'll scale with the object. You can parent by holding one object and letting go of it above another. You can see now it's kind of like a folder where I can drop down. Now if I move the parent, it'll move both of them. If I rotate the parent, it'll rotate both of them. If I scale, it'll scale both of them. If I use the rect tool, it'll also affect this one because this was a rectangle. Later on in Unity, you're going to have, oh, by the way, to unparent something, you hold the drag and then drag it back to a valid spot. Later on, you're going to have a lot of things on your left sidebar, every like block of your world. So you're going to want like folders to hide them. There's not really folders, but something you can do is just create an empty object and like treat it like a folder. And then you can just parent the things to it and then close the drop down so you can't see it anymore. Keep in mind though, it is parented, so if I ever move the folder, it'll move everything. When you create your Unity project, you
you created it 2D, which might make you think that like it's a different 2D engine, but in actuality, we're still in 3D. We're just literally all that 2D does is it sets the camera to 2D mode and it turns this 2D button on. If I press this, you can see we've actually been in 3D this whole time. By the way, in 3D, you can move around by holding right-click to move around, and then W, A, S, and D to move around, and Q and E to increase and decrease in height. So yeah, the main thing that makes 3D in Unity, 3D and 2D is the perspective of the camera. Is the whiteboard really quick? Sorry to you online people, but
I'll take a picture.
Yeah, that's probably a good idea. So let's pretend that this is just, I guess, two objects, and this is a camera. Your eyes in real life as well. Also, oh, it's on. There we go. Can you? Yeah. All right. Your eyes are a single point, so when you're seeing something, you're seeing it within your field of view. But you're also seeing each like atom from the single point. So pretend this was your view. You'd see the square, but you'd also see the edges around it. You can see it in 3D space. You can see a little bit of the top depending on what height you're at. And with the triangle, you can also see around edges and stuff. This is what makes 3D. This is perspective. And orthographic is a I guess, theoretical way of seeing things. It's infinitely many points pointing straight on. So there's infinite cameras looking as forward as you possibly can. So if I were to look through perspective, it would just be a square and a rectangle. I wouldn't see around the sides or anything. It's just head on at every possible point. Next. Let's go back to. Oh, this is the wrong thing. There we go. Next, a little side note with GitHub. I think Porter pointed this out last time, or he asked me about it. Since your sample scene, you can see I have to save it as a file. With GitHub, when you're uploading your file, when you're uploading your like push, you're overwriting the files that are on the on your GitHub like server. So the scene is actually saved not with like individual objects, but as one file. You can see in my scenes folder, samplescene.unity. So when you edit any part of the scene, it'll overwrite whatever was in the scene when you upload it to GitHub. So you should only really have one person uploading or editing a scene at once, because if someone's like working on something small in the scene and then someone else did a change to the scene and they upload it to GitHub, and then the other person sees that there's a change they need to sync with and they sync it, it'll undo all the work they did in the scene. Alright. So, importing sprites. I'm assuming you guys all know that sprites are just pictures. So you can just, I've already done it, but you can drag and drop the file into your folder. You can also make more folders if you want to sort, which you should. Oh, that's not, I'm going to click folder. Well, you can already see it made a scenes folder for us, but I can make like a scripts folder. And when I'm ready to make scripts, I can put it in there. So you could just create a 2D object and like give it some default thing and then change the sprite right here. You can see I can also drag and drop it in. Now it's a thing. Or you can literally just drag the sprite in. You might have noticed it's very small. That's because if I go back to the file itself, not the object I just created, these are the import settings. And you can see pixels per unit is set to 100. That means since this is it's in pixel art, it's very low res, so it's 16 by 16. So because the pixels per unit ratio is 100 pixels to 1 unit, it's only taking up 16 100ths of a unit. By the way, you might have noticed already that this whole thing's a grid. Each one of these individual squares is a unit, which I've been told is about equal to a meter in real life when you're using physics. So keep that in mind. This is just a Unity unit. So let's just say I want this to be like a whole unit. And by the way, you should definitely establish like pixels per unit for your whole project so that all the pixel art is the same size and the pixels are like a 1-to-1 to each other. I'll just say like each unit is going to be 16 pixels. And there we go. Now it's a unit if I were to put it exactly in one. You might have also noticed another problem with Unity. Pixel art is very blurry. It doesn't realize it's supposed to be pixel art. If I go back to my assets, I can go to filter mode. It has the bilinear filter on by default, which it treats it like a photo, which it isn't. You want to turn on point no filter, and then press apply, and then now it is pixel art. So I think almost all of us are doing pixel art, so make sure to do that every time you upload art. Oh, very important thing. If I were to create a script right now, I can just create a C# script, and I'll just call it like movement, because that's what it's going to be later. It is. Hopefully you guys also have Visual Studio installed. It was like optional when you installed Unity. You needed to obviously code. Yeah. Yeah. Yeah, you have to. Alright, cool. So this is what a default script looks like. I'll explain everything about this later, but because I have IntelliSense on, it'll take a second, but I'll get a random space before everything, see? Before everything of importance. And then a couple seconds later, it'll say like whatever references. This means I have IntelliSense on. IntelliSense is Unity's way of autocorrect. Visual Studio already comes with an autocorrect and tells you when you've coded in C# wrong. However, it doesn't understand the context of Unity correctly, whereas IntelliSense will also scan your other files to see not just if you've typed something wrong, but if the thing you typed doesn't make sense in the context of your project. So you really want IntelliSense on. If you opened it and it didn't take forever to load and you didn't get these spaces with Unity message, easiest fix, assuming that you installed everything already, if this reloads. Yeah, it's Edit, Preferences, External Tools. By default, this will be Open by File extension. You select Visual Studio, you check all these boxes, and then you regenerate project files. And then you had to have Visual Studio closed when that happened, by the way. And then if you reopened it and it still doesn't work, uncheck all these boxes, regenerate. If that didn't work, you might have a pop-up. There's this little tab called the Solution Explorer. I usually keep this closed, but there might be a little pop-up on the top right that says you're missing something, and then it'll say install in blue text. That means you didn't finish installing the Unity tools correctly. So click on that, and then it'll hopefully install IntelliSense. And if all else fails, then Window, Package Manager, make sure you have Visual Studio Editor installed. All right.
Remember, you can always message us on Discord if everything fails.
Yeah, if all else fails. I'm also going to close Solution Explorer just so I can have a complete full screen. There's also Git changes you can put on the sidebar, but I don't really care about that much. So for all of you that already know programming, you might have noticed that our class is inheriting from MonoBehavior. If I hover over it, IntelliSense also tells me MonoBehavior is the base class in which every Unity script derives. This is the difference between just a C# script and a Unity script. It's what inherits the methods like start, update, late update. It's what makes a script into a component. If you remove this, you're literally just coding in C#, which you can still do if you want to make like a data structure for something later on. So I'll just start. I know most of us already said that we know programming, but I'll start from the very basics. So I'm also going to skip a lot of like data types and loops. The most basic thing is an integer. As you probably learned in math class, an integer is a whole number. And to declare a variable, I just do the type of variable. So int is integer. I'll name the variable. I'll name it x, and then I'll set it equal to what I want it to be. Oh, what's up? Oh, right. Sorry. I can zoom in. There we go. Is that better? Also in C#, you have to end every like statement with a semicolon. It'll give you an error if you didn't. You'll know if you accidentally forgot. But I can do things like int y equals 4 as well. And then in C# to do math, I'll just do like int z equals. You can either, so a variable is basically just pointing to the value that you set it to. So if I use x as if it was a number, it won't read the letter x. It'll think, oh, the number that x represents. So I can do like x plus 1, and then z will equal to 4 as well, or I can do x plus y will equal 7. Then next thing is a float. I'll call it my float. A float is also a number. It's short for floating point value. However, it allows for decimals. So I'll just do like equals 1.3. Something very important with floats, you have to end the number with the letter f. If you don't end it with f, then it's a double, which is a float with double the storage space. However, in the context of Unity, you want to be using floats instead of doubles because the people who made Unity really love floats. Like, all this is floats instead of doubles, even though it could benefit from being doubles. So if you try to translate it to a float from a double, you'll get an error. Always just use floats. Obviously, same thing. You can just do like my float 2 equals 1.4f plus my float. By the way, quick thing with math in case you didn't know. Obviously, plus is addition, minus works as subtraction. For multiplication, you use an asterisk, and for division, you use a forward slash. Also, string. String is just a series of characters, and it's always in quotations. When I say characters, I don't just mean letters. I can obviously have letters. I can also have things like spaces, punctuation, etc. Numbers as well, yeah. When you do addition with strings, it will add the strings together. So I'll do my string plus my string 1. So this, because I did addition, it's just hello space world. So yeah, string addition is just adding to the end. Also, one last one is booleans. A boolean isn't a number. It's stored as a 0 or 1 technically, but a boolean is one of either two things. It's either true. Oops, true. Oh, I messed up my bracket. I know. It's either true or it's either false. The main reason you'd want to use a boolean is because of the next thing, which is if statements. I can type if and then parentheses. It'll automatically add the second parentheses. And then you can see with these, with void up and void start, I have these like the squiggly brackets. Those are like code containers. If I press the left one, it'll automatically add the right one. And if I press enter, it'll make a whole section for it instead of me having to write in one line. So, an if statement. If the thing that I write inside of the parentheses is true, the code will run. If it isn't, it will not run. So I'll make a bool called myBool. I'll set it to true. I'll make it so that if myBool equals true. By the way, you might have noticed, like I just said, I did 2 equals instead of 1 equals. 1 equals is setting equal to, so I set myBool equal to true. And double equals is equal to, as in the comparison this equals this, rather than setting myBool to true. So if myBool equals true, then I can set myBool to false. The next one I'm going to cover is else if. Else if is the same as if, however, it'll only run if the if statement before it did not run. Or if it's in a chain of a lot of else ifs, then it'll also run if like none of them have been selected at all. So else if myBool equals false, then myBool equals true, not equals. So I wrote boolean. So if this statement isn't true, it is true, so this will fire, and then it'll see, oh, that statement was true, so else doesn't exactly apply here, so it'll just completely ignore this. But if this was not true, like if I set myBool to false, this wouldn't run because this is not true. So instead, it'll check if this one has run, and if this one is true, and if it is true, it'll run what's in the block. And the last one is just else. Usually if you're doing like a giant chains of ifs and else ifs, it's the last one. If all else, if literally everything else above it never triggered, then just trigger whatever's in here. Any questions?
Any questions on Discord?
I'll take that as a no. So I'll get into methods later, but right now you can see we have two methods, start and update. If I make an integer in here, like int x equals 1, and then I try to reference it again later, like, oh, x equals 4. By the way, tried to do that. By the way, you only have to declare what type it is the first time you're like mentioning it. So if I did x equals 4 here, it would still work. But it doesn't work because if I hover over this, the name x does not exist in the current context. So you can see I've said we've been writing in containers. You can see there's like the giant container that contains all of this. Variables only really exist in the containers that they're in and the ones in the containers that are contained in the containers they're in. So int x will exist in start, but it'll also exist in an if statement inside of start and its containers. But that also means that x does not exist outside of start. So if I wanted like a variable that I'm affecting in start and update, I can declare it at the very beginning of my class, more on what a class is later, by just saying like int x equals 1, and then, that's minus 1. And then since I've declared what type it is, I don't even have to write int right here. It knows that the variable is here. By default, by the way, when you don't write anything before it, you're either going to write normally public or private. If you write nothing, it just assumes it's private. What public does is it lets other scripts reference it. So like if you had a variable and you only wanted this code to know about this variable, you'd make it private. If you had like variable and you wanted like another thing in your program to change it, you'd make it public. Another nice thing about public and private variables, it's reloading. I can also, like I said earlier, all you're doing when you're coding with MonoBehavior is you're making your own custom component. So if I go to the component search, you see my components there. Because I made it public, it also shows up in the sidebar of the inspector, and I can edit stuff here. It won't edit the code because of something I'll talk about later. But this is very nice for like if you you don't have to open the Visual Studio, but you want to quickly change a number or something, you can make it public. It doesn't have to be a number, it can also be like a string. I'll make the string nothing for now, but it'll update. And then I can write whatever I want and select it there. And then in my program, I can use whatever string was given for whatever I want to use it with. If for some reason you want it to be public so that other files can access it, but you don't want it visible in the inspector so that people can't mess around with it, you have to type in 2 square brackets, hide in inspector, and then you declare your variable. If instead it's private and you don't want other files to see it, but you do want the inspector to see it, you'd think it's show in inspector, but it's actually serialize field, and then even though it's private, it'll still show up here. Yep. By the way, you might have noticed the weird way I'm typing. This is called camel case. It's all the words combined into one word. Obviously, if I put a space, variables can't contain spaces, the names of them. But if I type in camel case, which is the first letter of each word is capitalized except for the first one, so the opposite of like normal English grammar, it's called camel case because it looks like with the uppercase letters that there's humps. If you type a variable name in camel case, Unity will read it and realize that these are supposed to be spaces in between words, and it will correctly format it. See? Now it has spaces, it's correctly capitalized it all. So here's a quick explanation of classes. You can see we've been writing in something called a class. A class is basically a data structure that it's a template for a data structure, and then we create clones of the template to fill with our own meaningful data. So I'll make a public class. You can also do it in the same file if you want, but you probably really shouldn't. I'll just do like student ID, which is a very typical one. And I'll do a public variable, public integer called like my ID, or not my, sorry, student ID. And then I'll do a public string of the student's name. And then I can use a class, since it's just like a template, I can create an object out of it. And it's basically like a variable where I just, now if I type student ID as if it was like int or float or string, it shows up. And I can name my variable. I'll name it the name of a student. But you might be wondering, usually with ints, you know, you set it equal to a number. With strings, you set it equal to a word. But this is not a specific thing. This is just like a group of things. Weirdly enough, with classes, you have to type new, and then the name of the class again, and then in parentheses. And then I can, if I want to access the variables inside of my class, I put a dot and then the name of the variable. Oh, why is that not? That's weird. Shouldn't this be working? Well, this should be working, but it would be the name of my object dot and then whatever variable I want to affect. And then I'll set it equal to, I don't know. Yeah, this should work. I'm not sure why I'm getting an error message. Oh, it's because I wrote it outside of update. Yeah, you can't write just like raw code. Yeah, you don't need a constructor for, I don't think any of the Unity like libraries use, well, you do for C#, but I don't think any of the Unity libraries use it. And then I can say like John.name equals, and then I can actually write out his name. And because I just cloned a template, I can also do like Amy equals new student ID, and then I can do Amy.studentID equals, and Amy.name equals. Yeah, basically, just to summarize, a class is just a data structure with variables and also methods, which I'm about to talk about. And then we can create clones of it and actually fill it with data we want. That's actually also what components are. They are technically objects of a class. You can see my movement script, how x is set to 20, because when I was back in the inspector, I manually set it to 20. But if I set x to like 13 here and I save, it doesn't overwrite it, because this is just a copy of the movement code. I've already filled in my own meaningful data that I want for this, so I can't change things after I've already set them. Same thing like if I set student ID here to 13, because I already set the student ID to whatever this is, even if I change the file of the class, it's still getting overridden by the thing I manually decided should be the student ID. Any questions, by the way? All right. Next. Oh, I'll do methods first. So a method is just, once again, a container of code. However, I can reuse it over and over. I'm going to delete all the code I've written to this point real quick. Probably shouldn't have done that, but... and I'll also keep it in the class, because the methods have to be in class. They can just be outside. I'll make a method. First, you have to do the return value, which I'll explain in a second. I'll just do a return value of int, and then the name of the argument, not the argument, sorry, the name of the method, and then inside of your parentheses, the argument, I'll just do int argument. So, like I said, you have to declare what you're returning. So I'm going to do, like, for instance, int x equals 441, and then int y equals, and then I can use my method as if it was a command. And the thing with the argument is, now if I hover over it, it states the requirements I've given int argument. You wouldn't normally name it the argument. You'd name it like something that hints at what you're supposed to be putting inside the parentheses. So obviously it's going to be my x. And I want doubler. I'm writing doubler to just double the number and then return it. So I'm just going to do argument equals argument times 2. And then I'll do return argument. So basically, now when int y reads this, like I said earlier, if it was just a variable, it would read the variable it's pointing to. But it sees this is pointing to not a variable or a number, but a whole chunk of code. And because it returns something, it'll run the code, and then whatever is being returned will be whatever comes here. So if I were to run this, y would be equal to 82. Does that make sense? If you don't want it to return anything, like you literally just want a piece of code that I can just keep writing over and over, like keep doing the thing without having to have like a giant block of text, you can see they did it here. It's void. I can also, if I go back to student ID, I can make, I have to declare them public as well, so that, well, you'll see later. I can make methods inside of my class, and then I'll actually copy over doubler. And then I can, when I create an instance of my student ID, I'll do once again John equals new student ID in brackets. Then I can also do John dot as if I was accessing a variable, but I can write, oh, I forgot to declare public, my bad. Once again, if you don't write private or public, it assumes it's private. I am also, that's true. Doubler. And then it'll work. Now quickly to static methods. You might have noticed doubler doesn't really have much to do with student ID. Like, it doesn't matter if I created my own object out of student ID. I can't like fill any meaningful information that would actually affect doubler. So for stuff like that, I would do public static int. That means it can't change. So even if I make an object out of this class, like nothing I do will actually affect anything that's in here. If you were to make a static variable, it means you can't change the variable. So because it's static and it has nothing to do with any meaningful information I'm putting into an object, I don't even need to make like an object of the class. I can just straight up do student ID dot doubler. And it doesn't matter if it's in a clone of it. It's just always going to be this, and it doesn't matter what information this is. The reason I mention that is because Unity has, well, most programming languages have these things called libraries. They're just classes made by Unity developers, but the whole point of them is using their variables and methods for things I want. For instance, if I wanted like pi, I could type out like 3.14f, but that's not very accurate. So Unity has a library. By the way, a library, like I said, it's just a class with information that we use, not like something we make a clone of and then fill with our own information. Unity has the mathf library with the pi variable. You're going to use a lot of mathf, so I can set, that would be a float by the way, obviously. I can set x equal to pi by using Unity's built-in classes. You might have noticed last time we also, when we were printing to the console here at the bottom, we used debug.log. And now you know debug is just a class made by someone at Unity, and log is just a method they made that will write it to console. So I can like put quotes here. And now if I run this, it'll use debug's log method to write to the console. What else? Yeah, so a lot of what you're going to be doing in Unity is just looking at the wiki, seeing all the libraries Unity gives you and all the many methods, things you can do. Like I said, there was debug. So I can go down here and find, I think debug's in here. Oh, was that it? There's debug. I can go to the debug library, and the wiki just shows all the things I can do with debug. Obviously, here's debug.log, and if I click it, it gives me an example code and a very in-depth description of what debug's log method does. And also, for instance, I can go to like, oh look, there's a library called random, and if I look through here because I'm looking to like choose a random number for my code, I can see, oh, there's a range method, and I just specify like the minimum and maximum number to choose from, and it returns a number. Yeah, that's just a lot of how you learn what you can do in Unity. Is just Googling to see if it's a thing that Unity gives you, so that you don't have to like make it from scratch. So now we can actually get to the actual coding, now that we're done with C#. I'm going to remove this as well. So we did go into a little bit of this last time, but it says right here as well, start is called before the first frame update. And also update is called once per frame. So any code I put in here will happen for here, for instance. You'd think this is when the game starts, but rather it's when the object, the earliest moment that the object exists. So if I were to debug.log, and I'll put an exclamation point, and obviously movement is already attached. Movement is already attached to the sample sprite object that I made earlier, so I don't have to like reattach it. It already has, so in its start, when it starts, it'll run debug.log because it has the movement component I made. You've already seen earlier at start when I was testing, the console said test. You can still see it. By the way, the most recent console line will always show up on the bottom in case you're only looking for one thing. You don't just switch all the way to console or whatever. But it's not specifically when the game starts. You can see there's a little checkbox up here. I can uncheck the object to disable it. And now that it's disabled, it didn't put it. But now if I let it exist, it'll put it. So it's the earliest that the object exists. And then update, self-explanatory. I assume you guys know what frames are in games. It'll happen every frame, so I can make something really annoying like this. Oh, right. And it'll do it every frame. Yeah, so now we'll get around to actually editing other components, which, like I said, that's the main thing you do in coding in Unity. You just make your component, edit the values of other components. So I'm going to make a simple movement, I guess, structure for now, and then I'm going to improve it in a second. Obviously, the thing I'm going to want to change is the transform component. You can see it has the position, rotation, and scale. So, like you saw earlier, all components are just a class. So I could make an object of the class. However, because every object has to have transform, like I said, if it's empty, it will already have transform because to be an object, you have to have a position. They've already done the liberty of creating a transform object of the transform class for us. So it's just called transform in all lowercase. This is the only thing this happened for, by the way. You're going to have to create an object of the class later on. And I'll do transform.position because I want to change the position variable. Before I do that, though, you might have noticed back when I was creating my own custom variables, it was like one line. Like they have one lines here. But transform has groupings of 3s. So you might be wondering how they have 3 variables in one line. In Unity, it's called a vector. For 2D, which all of us are doing, it's vector 2. And in 3D, it's vector 3. Or I guess it could also, there's no restrictions on it. But literally, all a vector is just a custom type of variable that holds more than one value. A vector 2 holds 2 variables, and vector 3 holds 3. And like I said, it is a class, so you do have to do the whole my whatever equals new vector 2. We've been leaving the parentheses empty, but some classes, like we were saying earlier, have arguments where for their constructor, where you can just type in what the vector is when it's being created. So to do a vector, you just do the first variable you want, comma, second one, and it has to be a float as well. And same thing with vector 3. New vector 3. 1, 2, 3. If I want to access each, oh, sorry, go ahead.
Is there a random library?
I think there is in C#, but I definitely recommend using Unity stuff rather than C# stuff, because I know for a fact just random is Unity's.
I was going to suggest if you could just like call the random for a random vector and
Oh, yeah, maybe. I was just gonna make it controllable for now, for like a basic movement. But if you want to, since it's a class, it's literally just storing these three as just variables, and the names they're named after coordinates. So the first variable in your vector is called x, the second one is y, and the third one is z. So if I want to do my vector dot x equals 2, it's already 2, sorry, equals 1, it'll just replace the first thing.
No one's doing 3D games.
I don't think so. Anyways, back to transform. Obviously, transform's public variable is a vector. It's a vector 3 to be more specific. Oh, and by the way, since we're working in 2D, the only coordinates you're going to have to worry about are x and y. The only thing that should have a z value is the camera that's negative 10 spaces away. If I go back here, you can see negative 10. For some reason, when you create an empty object, sometimes it'll have a z value. See, right here. It might mess you up if you're creating from empty and doing stuff from scratch, because you want everything to have a z value of 0. So just make sure to set stuff to 0. Also, if I set a vector 3 like equals a vector 2, it'll just overwrite the first two values, the x and y of the vector 3, which is important because I'm working in 2D, and position is always stored as in 3D, even if I created a 2D game. I'll do transform.position equals new vector 2. Like I said, even though it's a vector 3, if I do a vector 2, it'll replace the first two variables. And I'll just set it to an x value of 1 and a y value of 3. Obviously, transform literally reads these as coordinates. Even though a vector doesn't have to be coordinates, it can just be storing multiple variables. And you can see, I'll start off at 0, 0. I put that code in start, so the moment the object exists, you can see it has moved up. Oops, I accidentally full screened that. To 1, 3. Now I'm just going to quickly do a basic movement. I'll do an update because update keeps happening over and over. I don't want to just oh, thank you. Move the object once when it starts. Of course, transform.position. Oh, and by the way, a lot of Unity things, I can't just do transform.position.x equals 1, because for some reason the creators of Unity made it so that like a lot of their components variables in their vectors specifically are read only. So every time you want to transform the transform, even if it's just changing one of the several numbers, you have to do a whole vector. So transform.position equals a new vector. There is, oh, I think is this input? This was input. There is a library called input. I'm sure later on you guys are going to switch to like, there's a newer input system or something, but I'm just going to do like a very basic thing. And input has quite a few properties that I can use and methods. That includes the getAxisRaw method, which I'm going to be using. So I'll set my transform.position equal to current transform.position.x plus, and then the offset is going to be input.getAxisRaw, and then in quotations, in parentheses as well, name of the axis, left and right is horizontal, and then transform.position.y plus input.getAxisRaw, and as you might have guessed, vertical. So just a quick explanation of what getAxisRaw does. getAxisRaw, for horizontal specifically, it returns a number depending on what input is being pressed. It will return the number +1 if D or the right arrow key is being pressed, -1 if A or the left arrow key is being pressed, and 0 if neither of the buttons are being pressed. If you're on controller, it will return a float in between, depending on how hard left or right you're pulling it. It'll return a float in between -1 and 1. And then obviously vertical, same thing. W is W and up arrow is +1, S and down arrow -1, nothing is 0. I want to make quickly a point about this. I know most of us are platformers. Yeah, thank you. I think cast is top down. There is one thing you're going to want to note, specifically if you're using what I'm doing with input.getAccessRaw. So if I were to do a coordinate grid, let's say I want my horizontal, the net speed should be 1 in this example. Let's say on a keyboard, obviously, if they're holding D, that's 1. I'll just make the unit circle real quick. So if we were to treat input.getAccessRaw horizontal as the x value of something on a coordinate grid and the input.getAccessRaw vertical as the y value, if I was holding nothing, I would be here. If I was holding just D, I'd be here. Controllers, if I... Oh. I actually brought one today, and I'll show you in a second. Controllers, obviously I want my net speed to be 1, so the farthest you should be able to go in one direction is 1. Controllers have a circular hole cut out, unless you have like a weird square one. So if I was aiming top right, the farthest I can go is obviously a net of 1, because it's a circle. As you know, the radius is always 1 in every direction. However, sorry. However, if you are on keyboard, because it's using just whole numbers, if I hold D and W, for instance, or right arrow key and up arrow key, that's a positive value 1 and a positive value 1, meaning your net speed is the square root of 2. So if you're doing a top-down game, make sure to clamp the magnitude so that they can't go outside of a net speed of 1. Yes, that's the main point I wanted to make about that. So, back to this. Because this is happening every frame, I already realize since this is a whole unit is going to move every frame, I'm just going to multiply this by like a really small number, like 0.01f times 0.01f. By the way, any questions about this real quick? This whole long line. All right. And then I'll let this reload. Now I can do WD or left and right. And now I can move left and right. However, I'd like to make a point about this real quick. I'm on a laptop right now. I'm going to unplug my laptop and turn on battery saver. And now when I play, you'll notice I am substantially slower. The reason that is because if you remember, I'll unplug my laptop really quickly. Update is tied to the frame rate. So my physics are determined by how many FPS I'm getting. So you should never, ever, ever use update for physics-based things that have like a specific spacing. I'm going to quickly go over what you should do. But to do that, I'm going to also go over all of the built-in methods like these. You already know start. It happens when thing first exists. However, there's also awake. Awake is similar to start. There's a few key differences. You can't start a coroutine in awake, stuff like that. But more importantly, awake happens like a microsecond before start. So if you have two objects and one of them has to get a variable from the other right when the game starts, but you're not sure which one's going to the computer is going to calculate for first, because if the one that's supposed to send the signal calculates after the one that's supposed to receive it, it'll throw an error because it didn't get the thing. You can just make it happen in awake because it technically happens right before start. Next, I'll do late update. Late update happens at the same rate as update, but it'll only run after everything in update has run. So if you want to get the value, it's the same problem with you don't know what the computer is going to calculate first. So if I had something in update for another object and I wanted a different object to see what that was, I don't want it to accidentally get the data from last frame. I want it from this frame, so I'll make sure it happens after. And then finally is fixed update. This is where all physics-based things happen. So fixed update happens at a fixed rate, specifically your fixed time step, which is determined in your project settings under time. By default, it is 1/50th of a second. So I'm going to actually undo all the erasing I did. Because it's happening at every 1/50th, it's not tied to the frame rate. So now if I change this to fixed update, it will actually be consistent no matter how many FPS I'm getting. It's consistently slow because fixed update's now only happening every 1/50th of a second, whereas I was getting a lot more than 50 FPS. So you are usually going to want to multiply things by small numbers. I would also recommend, there's a library called Time, and Time has two important variables. Time.fixedDeltaTime is just the fixed time stat you set in edit. Sorry? What? Yeah, I know. It's the time you set in your settings. So this variable will literally just return 0.02. And there's also just time.deltaTime, which is more for normal update, and it's the time since the last frame. So you're going to want to use that for like timers and stuff. So one big problem, or actually before I get to that, you might have noticed that the movement's kind of bad, one that I made. So I'm going to introduce you to the most popular component, rigid body. If you remember from physics class, a rigid body is a theoretical object that is all the atoms are equally spaced apart, and it is infinitely not compressible. You might have seen like those YouTube videos with like the Tetris where everything's like floppy. That's soft body, which is the opposite. This is for solid objects. So by the way, because we're still in a 3D engine, things really like to default to 3D version. You can see there's two different versions of rigid body. Whenever there's two versions of something, obviously go with the 2D version. I'm just going to quickly explain everything. So now that I've added rigid body 2D, it has physics, which you'll see if I start. You can see it starts off with gravity. First, the body types. Dynamic is just your normal rigid body. Kinematic, you'll see if I select it, it removes a lot of the settings. It's just a more lightweight rigid body for things that aren't specifically meant to like move, just like to be there. Go ahead.
So what would you change if you're doing like top down instead of bottom? It's like the gravity to 0.
Yeah, that as well. Just also if you do kinematic doesn't have any gravity, but I assume dynamic would be better for movement because there's like linear drag and stuff, whatever. Yeah, so obviously kinematic's just a few less settings, make it a little more compact. Static is way less settings. You can't move static. It's the same as, or it's basically like having an unmovable object for like the ground. It's exactly the same as having no rigid body whatsoever. You might be wondering if it's the same as having no rigid body, why even have it? That's because in a collision, at least one of the two objects that's colliding has to have a rigid body connected to it. If they just have two hitboxes, but they're moving towards each other, they're just going to move straight through each other, because rigid body is the thing that's actually calculating, like, to stop when you're colliding. Where was it? So, another thing you're going to want to do with rigid body, rotation is on by default, which when you run into a corner, you're going to notice that just freeze rotation. Also, interpolate is very important. As I said earlier, fixed update happens every 50th of a second, and rigid body, by the way, also runs in fixed update. That means that our physics are running at 50 frames per second, which is not good. That means that even if I have like a 240 Hz monitor, the game is still running at 50 FPS for some reason. To fix that, rigid body has interpolate, which will create in-between frames for every frame. So even if like your speed is 1 meter per second, if it's fixed update, you'll only see it move 50 times, but if you have interpolate on, you'll see it move every time your computer can show it moving. So you're going to want interpolate on so that you can get actual like frame rate based movement that actually like looks smooth. Yeah, so now that I've showed that, I'm just going to do actual movement now. I shouldn't have deleted that probably. Yeah. So this is a very compact, I guess, movement code I've created. It's a vector 2. I'll call it goal speed. Because like I was saying earlier, I didn't really like how the thing turned out, where it was just I hold I let go and it stops moving. It's super jittery. It's just you go and then you let go and you're not. I want acceleration, deceleration. So I'm going to use I'm going to make a goal speed vector, new vector 2 obviously, and I'm just going to make it I'm just going to a platformer for now, so side to side. I'll do input obviously .get axis raw horizontal, and then I'll multiply it by a small number, of course. Actually, sorry, I'll multiply it by my goal speed, which I'll do for now 4 meters per second, and then input.get axis raw vertical. Oh, sorry, no vertical. I just want it to be plain horizontal. So, also, I said earlier that it already created the transform object for us, but we do have to create objects for the other components. Like my rigid body 2D, I'll make it out here and I'll call it RBody. Never name the variable name what the actual component is, because it'll glitch out if you do that. You'd think I'd do like new rigid body 2D because that's what we've been doing, but then I'm just making RBody into a rigid body, not the rigid body that I want. To make it the one you want, you use get component, and get component inside the angle brackets, you write the name of the component. And now RBody is equal to my rigid body of the object that this script is attached to. Now I can just do rbody.velocity.y, so I'm not changing y velocity whatsoever. Now I'll use rbody.velocity since I want to set the rigid body's velocity. If we go into vector 2, we can see there's a lot of different things we can do. But there's also move towards, and vector 2.move towards, it just moves one vector 2 towards another vector 2 by a step that you tell it to. So I'm going to do rbody.velocity equals vector 2.move towards. By the way, this is just a method of the library rather than me creating a vector 2, which is why I don't have to do like goal speed.move towards or whatever. Vector 2.move towards, and then the my rigid body's velocity vector 3. I want it to move towards my goal speed vector 2, a rate of, I'm just going to do a really small number again, 0.01. So now, oh, I forgot to turn off gravity again. Now I have very smooth movement. I guess the accelerate I put was way too small. But yeah, I can hold A and B to start accelerating, and then rbody.velocity will start moving towards the vector 2 that currently is just a value of 1 and a value of 0. So it just takes a step towards the goal speed every point by a rate of 0.01 every 1/50th of a second. And yeah, I think that's going to do it for today. Any last minute questions online as well? Oh, sorry, go ahead.
So just to review the third parameter and towards is the acceleration.
Yeah, it calls it on the wiki max distance delta. Any online questions? Because if not, then you're all free to go. Okay.